So let's talk a little bit about manual transmission diagnostics and what kind of problems you might run into past the clutch, okay? So we're not talking about clutch issues, throw-out bearing issues, pilot bearing issues, anything like that. Let's say you've had an internal transmission problem, you've been trying to diagnose, you've narrowed it down to something inside the transmission, so it needs to come out, be partially disassembled as you see these two units here. And now I need to figure out what's going on. So let's say maybe we had a hard time shifting into gear. You know, you're driving down the road, you're trying to get this thing to shift, maybe in the third or fourth gear, fifth gear, whatever the case is. You got your foot on the clutch pedal, you got the pedal all the way down to the floor, it just won't go, or you have to jam it in there to get it in. There's only so many things that can be. You've already verified that the throw-out bearing is releasing the clutch, or disengaging the clutch, so we can shift. You verified that the clutch plate's in good condition. Maybe it's a hydraulic clutch or a manual clutch. You look at your hydraulic system, where your clutch cable, things of that nature. So now I've got the transmission torn down. What's going on? Well, as far as what causes your transmission to shift into gear, there's only so many things that it can be. You have your shift control lever that's going to be in your transmission. You have your shift rails that are attached to your shift forks. Then you have all the pieces that make up your synchronizer that allow this thing to shift in and out of gear. So let's take a look at our shift rails first. So on this rear wheel drive unit, you can see my shift rails here. 3/4 shift rail, 1/2 shift rail, and then I got my 5th gear shift rail, and then my mechanism down here that will place this transmission into reverse for me. So on the shift rails, maybe one of them is bent. How that would get bent, being usually a solid piece of steel, would be difficult for me to wrap my mind around that unless somebody had really been extremely rough with the transmission. But you'd want to take this shift rail out, so you'd want to access the bolts for the shift rail, and there's going to be detent balls and springs in here too to keep the shift rails in their proper locations when you do shift it into gear. And roll this on a flat surface and make sure that it rolls true, that it's not damaged in any way. That checked out okay, you'd want to look at the shift fork and where the shift fork contacts the synchronizer sleeve. There's going to be a measurement in most cases that you can take and see if that's in spec. So in this case here, where the shift forks contact the synchronizer sleeves, I want to look at that gap there and then look up the spec on that and see if it's worn, if it's damaged, if it's excessive. There's something to think about too on a lot of manual transmissions. On the shift forks, it has little nylon inserts that go in them. They give you a little bit smoother shift. And those nylon inserts, in a lot of cases, you can replace them. They do wear out. So maybe that's what's going on. I'll give you a good example of that. A Borg Warner T5 that we used to work on in all the Fox body Mustangs back in the day had those little nylon inserts, and they would wear out, so that would cause issues. Just some things to look at. This particular unit right here does not use any of those nylon inserts. It has an aluminum shift fork and then a pretty high quality steel synchronizer sleeve, and as the aluminum wears and that gap opens up, that could cause us some issues, because now I have more distance that I have to move here to get this in and out of gear. So I need to look at that, and it's probably going to be best to remove the rail, remove the fork, get a real good close visual inspection on the shift fork, see if it's bent, then slide that shift fork down onto your synchronizer sleeve and take that measurement with a small feeler gauge to get that number. That same thing would apply on the front wheel drive unit too, because it has those exact same measurements. So just show you an example right here. We got a shift fork and a synchronizer sleeve from a front wheel drive transaxle. And if you look here, and I should have, here we go. If you look right here, in between that shift fork and that synchronizer sleeve, there's a small gap there, okay? So I need to measure the distance between the contact of my shift fork to my synchronizer sleeve with a feeler gauge and see where we're at. See if that number's excessive or not. If it's excessive, just look very closely at your synchronizer sleeve, make sure it's not damaged. Again, this is some pretty high quality steel. This is aluminum, so this is going to be your wear item. It's going to be your shift fork assembly. So you'll probably need to replace your shift fork. I would imagine that this is going to be okay. This would also require replacement of some other pieces because it is part of your synchronizer. Something else to think about is how does a synchronizer work, okay? So, you have your synchronizer sleeve right here. You have your synchronizer blocking ring. Of course, then you have your cone on your speed gear, and then your clutch teeth on your speed gear and your transmission. Let's say you have a unit where it grinds going into gear, or it just won't go into gear at all. You're trying to get this thing to shift into the next gear, and it will not go into gear. Well, let's think about how a synchronizer works. Let's not call this a blocking ring, let's call it a brake. That might make more sense. So as this gear's turning inside the transmission and I want to shift into this gear, this piece right here, my blocking ring, is my brake to get this gear to match the speed of the gear that I'm trying to shift out of, so I can shift into this gear without any gear clash. So you look inside this synchronizer ring, you're going to see that there's some paper clutch material in there. And this is out of a small front wheel drive transaxle. A lot of your higher performance rear wheel drive transmission, manual transmission assemblies, they have carbon fiber cones. And some of them will have what they call a triple cone synchronizer for your higher performance applications. It's just an old single cone synchronizer with bonded paper clutch material inside. So if I'm trying to shift into this gear and this gear's turning, as my synchronizer sleeve, this piece right here applies pressure onto that blocking ring, and that blocking ring should grab onto the cone of the speed gear and match my speed so we can get that smooth transition into this gear. Now, if I can't do that, I'm going to have some gear clash, and I actually may not be able to shift into gear at all, depending on how much this is worn. When this guy wears down and he's no longer working, it's going to be a good idea to replace the speed gear as well, because you could have some wear on your cone, on your speed gear. Like I would replace the synchronizer as an assembly, so that's my synchronizer hub, my synchronizer sleeve maybe in some cases, with the blocking rings and with the speed gear as well, because they all do kind of wear together, although this piece is going to be designed to wear at a much greater rate than this hardened steel cone on this speed gear. If you don't want to replace the speed gear, or that's not an option, you just need to get a new blocking ring and put it on your cone and then take a measurement. So if you look at this blocking ring right here, you can see that in between the blocking ring and the speed gear, there's a small gap there. All right, there's a small gap right there. There's going to be specifications for the particular unit that you're working on that tells you what that minimum gap will be. On this unit, my nominal gap, they tell me, is 39 thousandths of an inch. My minimum gap is 20 thousandths of an inch. So as this wears, this gap closes up. And if I get at 20 thousandths of an inch when I stick a feeler gauge in here, so if I take a feeler gauge, and I put it in here and I measure this gap, and it's less than 20 thousandths of an inch, it's time for me to replace some parts. Now, the proper way to measure these, and we're not always told this in the information we have available to us, in order for me to be able to measure this correctly, I need to be able to remove it from the transmission, because if it's mounted in the transmission this way on the main shaft, we're going to have some movement here, and I'm not really going to be able to get in there and get a correct measurement. So the proper way to measure these is to remove them, which it's going to require a lot of work, because on a main shaft on a manual transmission usually requires a hydraulic press and a bearing split plate to disassemble. I'm going to have to lay it on a flat surface. I want to take my hand and put some light palm pressure on top of that blocking ring. And then I want to get in here and measure that gap with a feeler gauge to get an accurate measurement. That is the only right way to take that measurement. So let's come back over here to this rear-wheel drive unit and take a look at it. See if I can get you a good view here. So on this unit here, here's my 1-2 shift fork, my 1-2 synchronizer sleeve, first gear speed gear, second gear speed gear. So if you look right here, there's my blocking ring for second gear. So when I get ready to shift into second gear, I need to get this gear turning at the same speed as the rest of this shaft so it doesn't grind going into gear. So that brass blocking ring right there acts as my brake to get that job done for me. I cannot get an accurate measurement of this gap with this assembled and installed on the transmission like this. I would have to get this main shaft out of the transmission. I have to break this main shaft all the way down, take this second gear speed gear, put it flat on the bench with the blocking ring on top of it, put my palm on top of the blocking ring to hold it down, and take that measurement of that gap with a feeler gauge. So if I measured it right now, I'm not going to be able to get an accurate measurement because it is moving, and I really can't get in here and hold it still where I can actually get an accurate measurement. So there's just some things to keep in mind. So to kind of recap, if I have a manual transmission and it's hard to get into gear or it grinds going into gear, you got your rails for your shift forks. You want to make sure they're not bent or damaged, scored, scarred, things of that nature. You got your shift forks themselves and the clearance between the shift fork and the synchronizer sleeve. Then you got your synchronizer assembly, which is your synchronizer sleeve, the synchronizer hub, and the brass blocking rings all make up parts of your synchronizers, okay? All those things would need to be inspected to see if we could pinpoint what is causing these to be hard to get into gear. Internal diagnostics of manual transmissions are actually very simple. There's really not a whole lot to look at. To me, this is way less complicated than an automatic transmission where I have hydraulic circuits and valves in the valve body and solenoids that I also have to factor in, plus clutch travel measurements and everything else on hydraulic clutches and clutch packs inside of an automatic transmission. So hopefully this is some good information and it helps simplify some of the diagnostics in our manual transmissions. Take care.